Okay, while I'm thinking about it, let me tell you what we got coming up next week. You've got, so we've got 5.4 and 5.5 to finish looking at in chapter 5. And I've already posted through 5.5 Math Excel, and you've got an online chapter 5 Math Excel test. So that's what I'm gonna do instead of doing a paper test for chapter 5. But it's not due until January 31st. So you've got all next week, and it's not due until like a week from Sunday. So please, please make sure you get that done. You've got 2 hours to take each attempt, and you've got 2 attempts for it. All right. How are y'all doing so far? Are any of you having issues getting into Math Excel? Like anybody? Oh, it's been kicking some people out for some reason. Okay, dividing polynomials. In 5.3, we factored them and solved polynomial equations. You're going to see how factoring kind of ties into division of polynomials as well. Okay, so there's 2. And I don't think you've ever seen division of polynomials, but we'll see. There's 2 ways of dividing. Tell me what method of division you learned a long time ago in elementary school. Do you remember what it was called? There you go. So there's also a long division of polynomials. And to me, that's the harder way, and definitely longer way. So we're going to look at that first. Then step 2, or well, the second way of division is synthetic. Every year when I teach this, we go through long division first and synthetic, and people don't like synthetic at first, but it usually ends up being their favorite method. You can always use long division for any type of dividing polynomial problem. So you can always use this no matter what. Synthetic division, you're going to see later on, there's a certain condition that has to apply in order for you to use its process. Okay, so we're going to work some long division problems first, and I'm going to go through the steps. We're going to write down the steps and then go through them. Okay, so tell me what do you call the expression that was under the house in elementary school? Do y'all remember what you called this? It was, starts with a D. Dividend. So what goes inside is your dividend, and what goes outside is your divisor. How you determine which polynomial is your divisor and your dividend, if a polynomial follows a division symbol, it's your divisor. So if it's behind a division symbol, it's your divisor. If it's in the denominator or bottom of a fraction, it's also divisor. So anything doing the dividing goes outside, and the other thing would go inside. Okay, so how you start off, you have to make sure that both your divisor and your dividend are in standard form. Do you guys remember from 5.1 what standard form is? It's when your exponents are in order from highest to lowest. There you go. Okay, so step 2, you have to make sure in both your divisor and dividend, you fill in zeros for missing terms. So you have to use placeholders. Fill in zeros for missing terms. Okay, step 3. To get your starting term of your answer, or your quotient, to get your starting term of your quotient or your answer, you divide the first or leading term, first term of dividend by the first term of your divisor. Divide the first term of your dividend by the first term of your divisor. Okay, step 4. You guys remember when you were doing long division in elementary school, you would find the first number that goes up here, and what would you do with that number? Once you found a number that went on top, what did you do with it? Good. It does come down somehow. Xander, what'd you say? You have to do what out front? You multiplied it back. So once you find each term of your answer, you have to multiply it back to your divisor. So multiply back to divisor. And then you remember, once you multiply that number back and you get what goes underneath, then you subtracted. So step 5, it's also very important on the step. You're going to subtract, but it's very important to know that your terms change signs. So all signs change. You'll see what I'm talking about in a minute. Okay, and then you just repeat that process. So you'll divide your first term of whatever you're left with by the first term of your divisor and keep repeating that process till you're done. Definitely seems like a lot of steps, but once we put numbers with it, I think it'll be, this will make sense and be a little bit better on you. Yes. Yeah, go ahead. Okay, Zima still needs to stop. Okay, your directions, once again, they're going to say divide using this method or whatever. Well, I just write that. I have that in my mind. Divide using long division. But you can use whichever method you want. Okay, the first problem, we have 4x squared plus 23x minus 16 divided by x plus 5. Now tell me which one should go outside and which one should go inside. Good. So I write x plus 5 here outside. Make sure you leave yourself some room at the top. And I should have told you this, but before you write your problem, always make sure that both of these are written in standard form. This is definitely in standard form. You got x squared, then x, then your number. This is in standard form because you have x to the first plus your number. And there's no missing terms. It goes x squared, then x, and 16. Somebody asked me what a missing term would look like. And it's if you had something like this, 2x to the third plus x minus 5. Tell me what that's missing. It's missing an x to the what? Second. So if you have x to the third, then your problem should go x cubed, and then it should have an x squared, it should have an x, and then a number. If it was x to the fourth, it should go x to the fourth, x to the third, x squared, so on. So that's what a missing term would look like. All right, for our purposes though, we don't have any missing terms and it's in standard form. So then we move on to the next step. You get your starting term of your answer by taking your leading term inside. What's my leading term inside? Good, 4x squared. So then you just come out to the side and do this in the margin somewhere. 4x squared, what's your leading term outside of your divisor? X. So I divide 4x squared by x. What do you do with exponents when you're dividing? When what'd you say? Good, you're gonna get 4x. You subtract exponents when you're dividing. So this x will cancel with 1 up here, you're left with an x, and then 4 divided by 1 is 4. Okay, you write 4x over its like term. So tell me, are you gonna write it over the first term, middle term, or the last one? Good, you're gonna write positive 4x here over its like term. Okay, you have to remember to multiply 4x back to every term in your divisor. So here comes the next step. So 4x times x is going to give you what? $4x squared. And you make sure you write it underneath its like term. And then 4x times positive 5 is positive 20x. So we multiplied, and what's next? Good, you subtract. So this is why in step 5, I told you to be very careful. Once I subtract, that's going to make both of these turn to negative. So my signs change here. Your leading terms should always cancel like down through your problem. So the 4x squareds cancel. I have a positive 23x minus 20x, which gives what? 3x. And remember, when you're dividing, you always bring down that next term. So bring down minus 16. Okay, from here, you repeat that process. What is your, so then I look here, what's your leading term here? 3x. So 3x, what's your leading term of your divisor? Good, x. And what, depending on what your divisor is, it's going to be the same thing every time. So 3x divided by x simplifies to what? Good, your x's cancel, so you're left with 3. You write positive or plus 3 over its like term, which is negative 16. Okay, last but not least, you have to make sure you multiply that to x and to positive 5. So 3 times x, that's going to give you 3x. Positive 3 times positive 5, 15. And when you subtract that, it changes both of them to minus. So then 3x cancel. Negative 16 minus 15 is negative 31. So how you know you're finished is when you've filled in your last term on top and you've multiplied it and subtracted it. Whatever you're left with is your remainder. Now, sometimes for polynomials, your remainder might be 0. It may be a negative positive whole number. It might be a fraction. Sometimes it can even be like another polynomial. Like your remainders might be ugly, like x plus 2 or something. So just know in some of these, if you get a crazy answer, it's more than likely correct. Okay, you don't have to write this next part down unless you want to. In Math Excel, they're going to give you a box. They're going to ask you what your quotient is. So they're going to give you a box for quotient. And in that box, you would type in 4x plus 3. Then they're going to give you a second box to type in your remainder. And of course, that would be negative 31. But in upper level math, this is the way you'll see it. They'll make you write your quotient, 4x plus 3. And then if you have a remainder, it's always plus that remainder divided by your divisor. So it's always remainder over divisor at the end. Okay, how do y'all feel about long division? Good. I was gonna say, if you looked at 5.4 already and was doing it, I can't imagine. I don't even want to know the way Math Excel explains it. All right, we'll do one more long division, then I'll show you synthetic. Does that paper look crooked? Yeah. Or is it lined up? Okay. All right, divide using long division or synthetic. Now, in this case, which one goes outside and is your divisor, and which one goes inside as your dividend? Which one? What'd y'all say? Good. The top goes inside. Now, so I'm going to write x plus 3 Notice, though, that x cubed plus 27 has a lot of missing terms. It should go x cubed, x squared, then x, and then a number. So this is how you fill in missing terms. you just write plus 0x squared plus 0x and then plus 27. And there's a reason that you fill in zeros, and I'll show you when we get through this problem. Okay, we start off, you have to make sure it's zeros, filled in for missing terms. It's in order from highest exponent to lowest, both of them, and they are. Then you look inside. What's your leading term inside? X cubed. So I divide my leading term inside by my leading term outside, which is x. What does that simplify to? Good. X squared. Where do you write x squared? Good. You write it at the top above its like term. So there's another reason why we fill in. If I didn't have that 0x squared there, I really wouldn't know where to write it. Then you make sure that you multiply x squared to x and 3. So x squared times x is going to give you x to the third power. X squared times positive 3, positive 3x squared. When you subtract, this x cubed becomes negative. This also becomes negative. The signs change. All right, when you combine like terms, x cubed minus x cubed cancels. You have 0x squared minus 3x squared, and then you can bring down your next term 0x. It just acts as a placeholder all the way through your problem. Okay, so you repeat that process. Your leading term here is negative 3x squared. You divide that by your leading term outside, which is x. What does this simplify to? Good, negative 3x. And you write that above 0x. Okay, once again, make sure you multiply negative 3x to everything out front. So negative 3x times x will give you negative 3x squared. Negative 3x times positive 3 is a negative 9x. What happens to those signs? Because we're going to subtract. So they're both going to become positive. So after you multiply, just know that your signs change. Okay, so that cancels. You're left with 9x. Bring down 27. Are y'all okay so far? Okay, we have to repeat it one more time because we got to fill in this last value. So your leading term here is what? Leading term here is 9x. And you're going to divide that by your leading term outside, which is x. Notice that what you divide by to get your terms, of course, always stays the same because that's not changing. Leading term outside is always the same. Okay, this simplifies to what? 9. So you write plus 9 at the top. And you have to make sure you multiply that as well. Then subtract, and we're done. So 9 times x plus 3 is going to give you 9x plus 27. But what happens to both of those signs? That one becomes minus. This one also becomes minus. What is your remainder? Good. 9x minus 9x, 27, all that cancels. So your remainder is 0, and your quotient is x squared minus 3x plus 9. Okay, how do you feel about long division? It's long, huh? Definitely lives up to its name. All right, for synthetic division, you can only use this method if your divisor is in the form x plus or minus some number k. Now that number can be a fraction, decimal, whole number, but as long as your divisor is in the form x, or of course any letter, z, y, whatever, plus or minus the number, you can use synthetic division. So you have to always check that first. All right, your steps, it's kind of hard to really put synthetic division in step form, but the first thing you do is write the opposite of the number with x that's in your divisor. So whatever number's with x, you're going to write the opposite of it. Write the opposite of the number with x in your divisor in a box at the top left of your problem. Okay, out to the right of that, you list the coefficients of your dividend. List the coefficients of your dividend. You're going to leave some room to work under those numbers. So leave a line. You can write that if you want to. You don't have to. Leave a line to work. You bring down the first number. So bring down first number. Numbers below the line get multiplied to the number in the box. Numbers below the line get multiplied to the number in the box. And you add down the columns. Like no matter what sign number you have, if you've got -7 and -5, you're going to say -7 like plus -5. So in other words, you're just simplifying the numbers down the column. Add down the columns. All right, number at the end will always be your remainder. Number at the end is your remainder. And I know that definitely sounds complicated. Maybe you'll like it better than long division. We'll see. Okay, number 3, we're going to divide using synthetic. Okay, so in order to use synthetic, your divisor has to be x plus or minus a number. Is it in that form? Yes, right? It's in that form, so we can use synthetic. Going back to your steps, how you start off in synthetic, take the opposite of the number that's in your divisor with x. So I'm going to do -3, and you put it in a box, the top left. Okay, from this point to the right of this, you list all the coefficients of your dividend. So we're going to go through every term. They are already in order. Your coefficient of x to the 4th is what? 1. Notice that you are missing an x to the 3rd power. So what do you put here? Good. Then what's your coefficient of x squared? -10. Leave yourself a little bit of room between those numbers as well. Then what's my next 2 numbers? Good, -2 and 4. Okay, the next part, I said to leave a line, so you're going to leave at least a line or so to work. You always bring down the first number. So from this point, your next step, I bring down this first number. Now, from here, your process that you follow, all of these numbers below the line will get multiplied by -3. So I multiply -3 to 1. And that gives you, of course, what? -3. You write that answer here. So I multiply that, but I write the answer here underneath the next number. And I told you that you add down the column. So you're just going to combine like 0 plus -3, which is what? -3. Okay, then I multiply that number times -3. That gives you what? positive 9. Okay, you add negative 10 plus 9 to get what? Negative 1. Then multiply negative 3 to negative 1. That gives you positive 3. Negative 2 plus 3 is 1. Multiply negative 3 to 1. That gives you negative 3. 4 plus negative 3 or 4 minus 3 is 1. This number at the end is always your remainder. So this has a remainder of 1. How you actually write your quotient or your answer, the numbers that you end up with on the bottom are coefficients of your answer or quotient. What was the degree of this polynomial? What's your highest exponent? 4. This was your dividend. So this is what got divided. Whenever you divide a polynomial, it always goes down 1 degree. So how you're going to write your answer, since this was a 4th degree polynomial and we divided it, it now becomes a 3rd degree. So this is going to be 1x to the 3rd. This coefficient goes in front of x squared. Then you've got minus 1x plus 1. And it had a remainder of 1, so this is technically how you're supposed to write it. You're supposed to say plus that remainder of 1 over the divisor of x plus 3. I know it's kind of gross. When you're doing synthetic division, this is always your remainder at the end. This number always represents your constant. The second number from the remainder to the left always represents your x term. Third from the remainder represents your x squared, so on. All right, how do y'all feel about synthetic? You may still like long division better. Okay, number 2, wait, 4. All right, number 4, you can divide using any method you want. Can you use synthetic division on this problem? Yes, good. All right. Tell me what number would go in this box. -5, good. Then you're going to list out coefficients. This is in standard form. It has no missing terms because it goes x to the 3rd, x squared, x, and a number. What numbers do you list here? What's all of your coefficients? Good. 177, -15. All right, always bring down this first number. And then you multiply -5 to 1. And you write that underneath the next number. Add down that column. So 7 minus 5 or 7 plus -5 is 2. multiply -5 to 2. And then 7 plus -10 is -3. -5 times -3 is +15. So what is your remainder? 0. I told you this number always represents your constant. This number always represents your x term. So we have +2x. The next number will represent x squared. So you have 1x squared. Okay, the next thing in 5.4, do y'all like synthetic division better? Or no? Y'all like long division better? Okay, the next thing in 5.4 that we got to talk about is the remainder theorem. Okay, so going back to those two problems that we just did using synthetic division, this is the first problem that we looked at. Notice that the answer we got when we synthetically divided, or the remainder rather, was 1. Pretty cool thing happens if you were to plug in, -3 into this polynomial, you would get an answer of 1. So I know you guys are familiar with those problems, pretty familiar. Like if I give you a function like this, 3x minus 2, and I said find f of 2, then you know that you would plug in 2 for x, right? And solve it. So that's just simple. If you replace 2 with x, plug in. Very similar thing is what the remainder theorem is telling you. If you have a polynomial and you divide it by x equal, or the opposite of whatever is with your factor, the remainder that you get is also the same as if you took that number and plugged in. So if I raise -3 to the 4th power minus 10, -3 squared, so on. So I think that's pretty cool. But that's now synthetic division did your long division, but to me, that is a long way of being able to plug in a number and get an answer. All right, I don't know how much sense that made, but so to dive in a little bit more. I bet the word theorem, like, just you guys do not like that word, from especially since you've been through geometry and proofs. Okay, let's say that you have a polynomial f of x. In Math Excel, they're going to say p of a. So they just name it a little bit different. So f of x or p of a doesn't matter. All this represents is function notation. They just use different letters to name different equations. So you have a polynomial. Now, if you divide this polynomial synthetically, so let's say you divide it by x minus some number, k. Divide it by x minus k. Or look, if you solve this, let's say that you solve this, then what would that be? Like, tell me what would make this, what value of x would make this 0? Well, okay. Excuse me. Let me back up. If I have this, x plus 3, and I know that this is a factor, remember in 5.3, I said you got to factor it, but to solve it, you would set it equal to 0. Yeah, so hopefully that helps you make sense of it. In some of these problems in Math Excel, they're going to give you divide this or find p of x equals -3. So they're going to give it to you already solved. So you have to be careful. But what you're actually dividing it by is x plus 3. So if they give you a equals 3, you're really dividing it by a minus 3. So you're going to divide synthetically by x minus k or x equals k. Now, there's two things that will work out. Either your remainder is going to be 0 or it's not. If your remainder comes out to equal 0, then x minus k is a factor of that polynomial. And you can actually use the answer you get to completely factor it. So x minus k is a factor, and you can use that to factor the entire polynomial and keep going. Okay, so if your remainder is not equal to 0, then if you plugged in k, whatever the opposite of x is, or if they actually say x equals that number, so if you plugged in that number, you would simply get your remainder value. So if your remainder equals 0, then x minus k is a factor of that polynomial. If your remainder is not 0, then it's not a factor. But if you were to plug in the number into your function, you would get your remainder value. Is that clear as mud? All right, I'm gonna show you one problem. I think this may be like number 12 in your Math Excel. I'm not for sure. So 5. Use the remainder theorem to evaluate the function at x equals -2. Notice they give you what you would actually be dividing by. They give it to you already solved. So this x equals -2 is the same thing as if they gave you x plus 2. I need to take very good note of that. If they give you the actual value of the variable, then it's the same thing as you're dividing by the opposite of it. All right, so when you use the remainder theorem, you're going to synthetically divide. And this is your function they give you. Okay, so they gave you x equals -2, which is the same thing as x plus 2. So when you synthetically divide, remember I told you to always do the opposite of x. But if they tell you that x equals a value, that's what you're going to actually use to synthetically divide. I know that's confusing probably. Okay. So use the value you're given to divide. Your coefficients are 3, 8, 5, -7. Okay, you're going to bring down 3. You're going to multiply -2 to 3. Eight plus -6 is 2. Multiply -2 to 2, get -4. And then this will give you -2. And -7 plus -2 is -9. Okay, so we got a remainder of -9. So that's your answer. We use the remainder theorem, which is synthetically dividing, and we evaluated this function at a value of -2. Now, the easiest way that you're, familiar with is if you simply just take -2 and plug in. So you can do it either way. You can just type this in your calculator, 3 times -2 cubed, 8 -2 squared, 5 times -2 plus 7, and you're going to get -9. Okay, very last thing, I promise. All right, last theorem in 5.4 is the factor theorem, and we've already talked about it. If you divide by a polynomial, so let's say you divide by x minus 2, if you get a remainder of 0, if your remainder equals 0, then x plus or minus k is a factor. And you're going to be asked that in 5.4 Math Excel. They're going to say use the factor theorem to determine if x plus 5 is a factor. And then they may even ask you to go on and factor it. So I'm going to show you what that looks like. That's 3, 2, yeah. They're going to say use factor theorem to completely factor. Some problems will just say, is this a factor of it? And if you divide, get a remainder of 0, yes. If not, no. Use factor theorem to completely factor it. We've got x plus 5 is your divisor. Okay, that's all right. That's the one that we just did. Yeah. Yeah. Oh my God, yeah. Okay, we just synthetically divided that, and we got this. You don't have to write it down again. You can just say refer back to number 4. Okay, you're left with x squared plus 2x minus 3. Now that we have a remainder of 0, I know that x plus 5 is a factor of this polynomial. So I can use the remaining polynomial to completely factor it. From this point, tell me how x squared plus 2x minus 3 factors. What are two numbers multiplied by 3? Are the only two numbers multiplied by 3 that subtract 2? Positive 3 and negative 1. So completely factored, this polynomial is x plus 5, x plus 3, x minus 1. Be careful in Math Excel though, because if they ask you to do this, they're already going to put x plus 5 there for you and then give you a box to type in the other two that you find. So just look out for that. Okay, y'all have any questions? Kind of a lot to take in, I know, especially like the theorems. We're going to do some more with the theorems in section 5.5 too. But all right, you've got 12 problems in your 5.4 Math Excel, so y'all can use the rest of the class to work on that. Thank you.